So trigonometric functions of an angle. Take note, there are 6 basic trig functions from among the different other functions that you might see. We'll be focusing on the 6 trig functions. So the trigonometric functions are periodic functions, which denote the relationship between angle and the sides of a right-angled triangle. So again, the trig functions are applicable only for right triangles. So what are the parts of a right triangle? You have the vertex, let's say vertex B. You have the legs, A, B, and C. They're all the sides. But then typically, the longest among the legs is what we call the hypotenuse. So in this case, hypotenuse is C. So let's consider, in this case, they're considering all angle A's. So let's consider this angle, angle A. This one. If you're considering angle A, sine is opposite over hypotenuse. Remember, this is sine is opposite over hypotenuse. So, and then cosine of A is adjacent, which is letter B, side B, all over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent of A is opposite over adjacent side. So tangent is O over A. But what you will notice is that in here, if you focus on the fractions, A over C, B over C, can I see that tangent of A is actually sine of A over cosine of A? Because A over C divided by B over C is actually A over B. That one of the properties of sine, of tangent, is that tangent of A is sine of A all over cosine of A. Now, the other 3 functions, typically, once you know the first 3 functions, the other 3 functions will just follow. Why? Because they are reciprocals of what you have. So you have the tangent. It's actually the reciprocal. It's B over A if it's cotangent. For cosine, which is B over C, the reciprocal of this is secant, which is C over B. And then lastly, sine, which is A over C, the reciprocal is cosecant, which is C over A. So again, the reciprocal of sine is cosecant, reciprocal of cosine is secant, reciprocal of tangent is cotangent. Whereas the relationship between sine and cosine, tangent and cotangent, secant and cosecant, they are what you call cofunctions. So sine, cofunction ng sine is cosine. Tangent, it's cotangent. For secant, it's cosecant. So for tangent and cotangent, they're both cofunctions and reciprocal functions. So let's just consider any angle in here. Let's just say theta is an angle, an acute angle in the standard position. So if we have, let's just say P, point P passing through XY, we can actually solve for that distance. Because if we draw a triangle in here, we know that this one, if we consider this angle theta, this side here at the base is your adjacent side. And then the side, which is the y there, side opposite theta is your y, that's opposite. And then it forms a right angled triangle. So since it's right angle, we can solve for the hypotenuse by solving for r using r squared is equal to x squared plus y squared, the Pythagorean relationship, right? Because this is a right triangle. Now, looking at this figure, what is sine of theta? It's opposite over hypotenuse, y over r. Cosine would be x over r. Whereas tangent is opposite over adjacent, so y over x. But then look at this. For tangent, I place there x cannot be 0. right? X cannot be 0 because if X is 0, it becomes undefined. So you have to have a value of X for tangent. For cotangent, you have to have a value for Y. And then again, secant is the reciprocal of cosine. So if cosine is X over R, secant will be R over X. Since X is underneath, X cannot be 0. For cosecant, similarly, it's the reciprocal of sine. Therefore, this becomes R over Y. Y cannot be 0. Some of you might ask, why is it that for sine theta and cosine theta, I did not indicate here that R cannot be 0? Because if it's a circle, a unit circle or whatever in here, if there are points here, you will never have a 0 radius. Otherwise, there's nothing to solve, right? Okay, so let's just try. Let theta be an angle in the standard position whose terminal side passes through this point, -3, 4. And then you're asked to find the 6 trig functions of theta. So since this one here, that is a 3, 4, 5 triangle, it's a right triangle. So what I usually do is I indicate if it's to the left, it's negative. So I know that I'm solving for this angle here. Let's just say this is theta. So going up, that's a positive y, so that's positive 4. Going to the left, that's a negative x. The radius can never be negative. So let's solve. Sine of theta based on the triangle is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Lastly, tangent of theta is opposite over adjacent. So that's negative. Now, since you're asked to solve for the 6, this one would be cotangent, this one would be secant, and then this is cosecant. For cotangent, it would be the reciprocal of tangent. So that's -3 over 4. For secant, it's the reciprocal of cosine, -5 over 3. Lastly, for cosecant, it's the reciprocal of sine, so it's +5 over 4. So again, using the triangle, we were able to solve for the 6 trig functions. So here, so let theta be an angle in the standard position whose terminal side passes through point 3, -3. So you'll notice that this one is in the 4th quadrant where x is positive and y is negative. So 3, -3 is here. So let's just draw the right triangle here. This is your theta. That means 3 is to the right, -3 goes down. So we have to solve for the hypotenuse. So you'll notice that applying the Pythagorean theorem, let's just say r, the radius is the hypotenuse. R squared is 9 plus 9 or 18. Therefore, r is 3 square root of 2, right? So let's solve for the other thing that's being asked, which are the 6 trig functions. So for the 6 trig functions, sine of theta is opposite over hypotenuse. Now this one can be fixed. This can be written as -1 over square root of 2. However, you recall from your previous mathematics that you cannot have radicals at the denominator. So maybe we can rationalize this by multiplying both numerator and denominator by square root of 2. So this changes to negative square root of 2 over 2. Cosine is adjacent over hypotenuse. So again, we can simplify this. that becomes square root of 2 over 2. And then tangent of theta, opposite over adjacent. So opposite over adjacent, that's -1. So after we write the 3, we can solve for the other 3. Cotangent, secant theta, and cosecant of theta. Cotangent of theta is just the reciprocal of -1, so it's still -1. Secant of theta is just the reciprocal of cosine. Before we rationalized this, cosine was 1 over square root of 2. Therefore, secant is square root of 2. Lastly, cosecant is the reciprocal of sine. Before we rationalized it, it was 1 over square root of 2 negative. So this one is actually negative square root of 2. All right. So there are questions. How did we get a -3 in here? Take note. The point is positive x, negative y. So positive x, it goes to the right. Y is negative, it goes down. Right? Therefore, it's in the fourth quadrant. This is the point. Okay. So now this is just to recall if you have learned some trigonometry way back in junior high. The trigonometric functions of an angle, you'll notice that here in the Cartesian plane, I placed here some mnemonics, some acronyms, SATC. For me, this is to just recall this as Sex and the City, the movie Sex and the City. So you'll notice that here in the first quadrant, all trigonometric functions are positive. Take note, what is the reciprocal of sine? It's cosecant. So I'll just take note of the first 3 functions, sine, cosine, and tangent. So sine here is positive, including its reciprocal, which is cosecant. In the third quadrant, t, which is tangent, and its reciprocal, of course, the cotangent, is positive. And in quadrant number 4, cosine and its reciprocal, which is secant, they're both positive. So again, Sex and the City. So this is what was meant by this. So in quadrant number 1, since x and y are positive, all are positive. Since in quadrant 2, x is negative and y is positive, everything that includes x will be negative. So look at this. X, y, and r, right? So in the first quadrant, since both x and y are positive, everything's positive. In the second quadrant, since x is negative, everything that involves x, so tangent, secant, cosine, and cotangent are negative. Only those that don't contain x, which is y over r and r over y, are positive. There. So please take note of these. Again, let theta be an angle in standard position whose terminal side passes through 2, -4. So you'll notice 2, -4 again in the fourth quadrant. So 2 across and then -4, 1, 2, 3, 4, -4. So it's this point. So let's consider this triangle. By the way, the triangles, when you draw triangles all the time, it should be in reference with the x-axis, not in reference with the y-axis. So it's that angle. The thing is, we still don't know the hypotenuse. So 2 squared is 4, 4 squared is 16. So this is square root of 20, or 2, 5 times 4, diba? 2 squared of 5. Square root of 20 is 2 squared of 5. Right? Find the 6 trig functions. Sine is opposite over hypotenuse. So let's simplify first. 2 over square root of 5. If we rationalize this, square root of 5 over 5. Cosine is adjacent over hypotenuse. So that's square root of 5 over 5 because it becomes 1 over square root of 5. And then you have tangent, opposite over adjacent, negative 4 over 2. That's negative 2. Therefore, cotangent of theta is negative 1/2. Secant of theta is square root of 5. And then cosecant of theta is negative square root of 5 over 2. And then look at this. In the fourth quadrant, if we recall SATC, in the fourth quadrant, cosine and its reciprocal are positive. So it's correct. Only cosine and secant are positive. The rest would be negative. So again, how did we get the radius? Radius squared is 2 squared plus negative 4 squared. So that is 4 plus 16. That's 20. Therefore, 4 times 5. So 2 square root of 5. So earlier, it's just about any angle. This one, it can be any angle, so long as you're given a point. But now I'll be teaching you the trigonometric functions of the special angles. So when we say special angles, they are the 30, 45, 60, and their factors, their multiples. So let's go to the 30, 60, 90 triangle. So theorem, in a 30, 60, 90 triangle, the length of the side opposite 30 is 1/2 that of the hypotenuse. So sometimes it may be drawn like this because usually the reason why the hypotenuse is set to 1 is because of the purpose of drawing it in a unit circle. But sometimes, like with me, what I draw is this. If this is 90, obviously that top one is 60. So it's basically the same. It's just that the ratios are the same. So with me, if I multiplied everything here by 2, the 1 becomes 2, the 1/2 becomes 1, the square root of 3 over 2 becomes square root of 3, so that I don't have any fractions. But look at sine of 30. Sine of 30 is opposite, which is 1/2, over hypotenuse. So 1/2 divided by 1 is 1/2. But if I use my triangle, the red triangle here, sine of 30 is opposite, which is 1 over 2, still 1/2. Like with me personally, I usually draw my own 30, 60, 90 triangle, and I don't use the fractions. What I use are these ones, 1, 2, and then square root of 3. And then let's go to the 60. Sine of 60 degrees in here is opposite over hypotenuse, square root of 3 over 2 over 1. So that's it. But with me using my triangle, sine of 60 is opposite, which is square root of 3 over 2, which is this one. Okay? And look at what's special with the co-functions, guys. As I said, sine and cosine are co-functions, right? And then 30 and 60 are complementary angles. So the sine of 30 is actually equal to the cosine of its complementary. Look, what's the complementary of 30? 60. Kasi co-function siya, it should be the co-function. The co-function of sine is cosine. That's why sine of 30 is the same as cosine of 60 degrees. You'll notice that cosine of 30 degrees is the same as the sine of 60 because they're co-functions. The partner angle that they'll be equivalent with are the complementary angles. Now, let's go to the 45, 45, 90 triangle. This is otherwise known as the isosceles right triangle. So with me, instead of like using those fractions, what I do is this. That's a symbol that they are congruent, right? So 1, I use square root of 2 on the other side. Pretty much they're the same. So according to this one, let's use A. Sine of 45 degrees is square root of 2 over 2 divided by 1, which is square root of 2 over 2. Using my triangle, sine of 45 is 1 divided by square root of 2. And then 1 over square root of 2, when you rationalize that, is actually equal to square root of 2 over 2. So with this, let's try going to this. Basing on the triangles below, guys, can you help me fill out what is sine of 30 based on the triangles below? Sine of 30 is 1/2. Very good. What is sine of 60 based on the triangle below? It is square root of 3 over 2. Very good. What about cosine of 30? Square root of 3 over 2. Cosine of 60, isn't it 1/2? And then tangent of 30, based on the triangle, 1 over square root of 3. It's okay. Don't rationalize yet now. I'll ask you to rationalize later on. What about tangent of 60? Square root of 3. Let's fill out the 30 and 60 first, and then later on, let's fill out the 45. The cotangent, it's just the reciprocal of this. So this one is 1 over square root of 3. Secant is the reciprocal of cosine. So 2 over square root of 3. This is 2. Cosecant is the reciprocal of sine. So that's 2. This is 2 over square root of 3. So let's go to the functions of 45. Sine of 45 is what? 1 over square root of 2. What about cosine? It's also the same. 1 over square root of 2. For tangent, opposite over adjacent. So 1. Cotangent, just the reciprocal of this, is 1. Secant is the reciprocal of cosine. So that is root of 2. Lastly, cosecant is the reciprocal of sine. It's root of 2. So as I said, keep them as is for the meantime. But of course, as your final answers, I would like them to be rationalized. Okay? This is for the purpose of filling out the table only. Okay, now, let's go back to the reference angle, but then I'm going to give you something that's probably more than one revolution, or probably not in the first quadrant. So the reference angle is the acute angle formed between the terminal side and the x-axis. So it does not necessarily mean that it has to be the positive x-axis. So long as it's the x-axis referenced, it is the reference angle. It's an acute angle, okay? So for letter A, number 1, it says they're 120 degrees. 120 degrees, guys, is greater than 90, but less than 180. So in which quadrant does it lie? In the second quadrant. Now, if it's in the second quadrant, what we do here is it has to be in reference with the x-axis. So it has to be this theta. So if this is 120, you subtract it from 80. 80 minus 120 is what? 180 minus 120 is what? It's 60 degrees in quadrant number 2. Okay, let's go to number 2. Negative 135 degrees. Some of you might say, sir, it's negative. Yes, it's okay. What we do here is we add 1 revolution. Can you add 360 to negative 135? What will it become? This becomes, am I correct, 225? Now, 225, you know that it's greater than 180 but less than 270. So with that, you know that it's in quadrant number 3. So if it's greater than 180, you want it to be in reference with the x-axis. It's this angle. So 225 minus 180 is what? It's 45 degrees in quadrant number 3. Very good. And then here, it's 315. You know that 315 is greater than 270 but less than 360. So you know that it is a quadrant 4 angle. So if it's closer to 360, subtract it from 360. What's 360 minus 315? It's 45 degrees in quadrant number 4 because it's this one. You understand? Okay. Number 4. 2 pi over 3 radians. Some of you might ask, sir, it's difficult. Is it okay if we convert this to degrees? It's okay. Pi, 2 pi is actually 360. 360 divided by 3 is actually 120 degrees, right? So 120 degrees, but I'm asking for a reference acute angle. So since it's closer to 180, what we do here is 180 minus 120, that's actually 60 degrees or pi over 3 in quadrant number 2. Okay? Lastly, there's a problem with number 5. It's only 3 radians. It did not mention anything about pi. So how do we change this to degrees? Just to check. Pi radians is 180 degrees. Can you use your calculator? 3 times 180 degrees divided by pi is 3.141 something. Can you give me the angle here? 171.89 degrees. So this one, you know that this one is greater than 90 but less than 180. So can you give me the acute angle equivalent to this? So it's 9.11 degrees in which quadrant, guys? Is it 9.11 or 8.11? It's 8.11 degrees in quadrant number 2. Very good. So that is how we change it. All right. So here, let's continue answering. The angle in degrees is, so this is 30 degrees times 5. So am I correct in saying that this is 150 degrees? This is 30 degrees times 7, 210 degrees. This is 60 times 4. That's 240 degrees. Am I correct? This is 60. No, sorry. Pi over 4. That's 45 times 5. What's 45 times 5, guys? That is 225 degrees. Lastly, this is 45 times 3. What's 45 times 3? That's 135 degrees. Okay. I'm asking for a reference angle again. Reference angles are angles that are acute and in reference with the x-axis. So 150 degrees is close to 180. So let's subtract it from 180. 180 minus 150 is 30 degrees in quadrant number 2. 210 degrees is close to 180 as well. So that means 210 minus 180, that's 30 degrees as well, but this is found in quadrant number. Next, 240, you know that that's greater than 180. So let's subtract 180 from it. This becomes 60 degrees. In which quadrant? You know that this is in quadrant number 3. And then 225, you know that that's greater than 180 but less than 270. So that's in quadrant 3 again. So let's subtract 180 from this. That is 45 degrees in quadrant 3. Lastly, 135. Oh, it's less than 180 but greater than 90. So that's found in quadrant number 2 only. So 180 minus 135 is 45 degrees. Next, now using reference angles, find the value of cosine of 150. So guys, 150, you know that 150 is quadrant number 2 angle. But then what angle in quadrant number 2 is that? That is 30 degrees in quadrant number 2. Isn't it that 30 degrees in quadrant number 2? Opposite is 1. And then this is 2. This is square root of 3. However, going to the left, x is negative. Right? So, I can say that cosine of 150 degrees is adjacent, which is negative square root of 3 over 2. Can you follow? Because in quadrant number 2, cosine would be negative. This is number 1. Number 2, find the value of cosecant of 210. First, let's look at 210. That's greater than 180. So, somewhere here is your reference angle. But what is the reference angle? 210 minus 180, that is actually 30 degrees in the third quadrant. So, 1, 2, square root of 3. Take note, in quadrant number 3, it's going to the left, so negative yung x, going down, negative the y. And it's cosecant. Cosecant 210 is actually hypotenuse over opposite. So hypotenuse over opposite. So the answer is negative 2. Alright, sige. Look at this. 240 degrees. 240 degrees is in which quadrant, guys? Quadrant number 3. Right? Okay. So that means I need to draw a quadrant number 3 triangle. And then this one has, it's greater than 180. So 240 minus 180, this is 60 degrees. You know that opposite 30 is 1. Opposite 60 is square root of 3. Then this is 2. Since it's in quadrant number 3, guys, what happens is the x is negative, the y is also negative. I'm looking for tangent of 240. Some might say tangent of 240 in the third quadrant, it's still positive, so they just rewrite it as tangent. But with me, let's keep it like this first. Tangent of 240 is opposite over adjacent. So the answer is square root of 3. This one's quite difficult because it is in terms of pi. So maybe we can use what we learned earlier. 3 pi over 4 is actually 3 times 45 degrees. So 135 degrees. We can rewrite that. Sine of 135 degrees. Okay. We know that 135 degrees is in the second quadrant, right? This one, 135. So the reference angle would be a 45-degree angle. So since it's 45 degrees, the special triangle that we will be using is the 1, 1 square root of 2. Because again, going back to what I have taught you, there are 2 special triangles. The 1, 1 square root of 2, which is the 45, 45, and the 1 square root of 3, 2 triangle, the 30, 60, 90. All right. So sine of 135 is opposite over hypotenuse, or root 2 over 2. By the way, I forgot to place here the negative. But it still doesn't matter. Why? Because for sine, the opposite is positive. The adjacent here is negative. So the cosine will be negative if I'm asking for cosine. Now, I'm giving you last 3 examples. But then for the last 3 examples, it's quite special because look at this. If theta is an acute angle in quadrant number 2, you're already given that theta is in quadrant number 2. And then cosine is negative 4 over 5. So cosine adjacent, I can say that adjacent could be negative 4, hypotenuse could be 5. So if I were to look for this one, let's just say y, 5 squared is equal to negative 4 squared plus y squared. Y squared is 25 minus 16, which is 9. I can see that my y is 3. So it says there, draw the triangle and find the other trig functions. So sine, tangent, cotangent, secant, and cosecant. You already know the cosine. The cosine is given as negative 4 over 5. What is the sine based on the angle? Opposite over hypotenuse. The opposite is 3. Hypotenuse is 5. Tangent, opposite, which is 3, over adjacent, negative 4. Therefore, I can solve for the cotangent by looking at this. It's negative 4/3. Secant is just the reciprocal of cosine. You already know what cosine is. Negative 4/5 from the top. So it's negative 5/4. And then cosecant is the reciprocal of sine. 5/3. Okay? So to understand this further, I'm going to give another example. Angle alpha. It says there, angle alpha is an acute angle. Okay, I just don't know whether it's in the first, second, third, or fourth quadrant. However, it says there, guys, that tangent alpha is less than 0, and then cosine of alpha is greater than 0. Remember this. For tangent to be negative, what quadrants is tangent negative? Tangent is positive in the third quadrant, am I correct? So which quadrants is tangent negative? Quadrants 2 and 4. Now, it says here cosine is positive. Where is cosine positive? In which quadrants is cosine positive? Quadrant 1 and quadrant 4, because in quadrant 1, all are positive. Now, which one repeated? Isn't it that quadrant 4 repeated? So that means your angle alpha should be drawn in the fourth quadrant. In here. Alpha, it says their tangent opposite, adjacent. Since y is going down, let's place negative in there. X, it's positive. So we don't know the radius. We can say that radius squared is square root of 3 squared plus negative 1 squared. So this is 3 plus 1, which is 4. Therefore, R is 2. 2. You're asked to solve for the other trig functions. Sine, cosine, you know what the tangent is. We can solve for the cotangent, secant, and the cosecant. So looking at the triangle, sine would be opposite over hypotenuse, negative 1/2. Cosine would be adjacent over hypotenuse, square root of 3 over 2. Cotangent is just the reciprocal of sine, or you can look at this one. Instead of opposite over adjacent, it's adjacent over opposite. It's negative root of 3. Secant is adjacent, hypotenuse over adjacent, so that is 2 over square root of 3, or 2 root 3 over 3. Lastly, cosecant is hypotenuse over opposite, so negative 2. And then look at this, guys. Isn't it that tangent and its reciprocal are both negative? Ayun, no? Tama. And then cosine, really, cosine is positive in the fourth quadrant. And its inverse, which is secant. Okay? So let's go to the last number. If beta is an acute angle, cosecant of beta is negative 5/3. So it says there, cosecant beta is negative. So cosecant is the reciprocal of sine. So I can say that sine is also negative. And it says there, cosine of beta is also negative. When, guys, is, so looking at this, when is sine negative? In which quadrants? Can you dictate to me? Sine is negative in quadrants 3 and 4. When is cosine negative? In which quadrants? Cosine is negative in 2 and 3, right? Kasi here, cosine of beta is negative daw. Cosine is beta, cosine is positive in the fourth and first. Therefore, it's going to be negative in the second and third. So, which one repeated? The third quadrant repeated. Meaning, I need to draw my angle in the third quadrant. Here, this is where the angle beta is. So it says there cosecant. What is cosecant? Hypotenuse over opposite, right? So it's going down, it's negative. The thing is, we don't know the x. 5 squared is negative 3 squared plus x squared. X squared is 25 minus 9. X is 4. But since it's going to the left, I can see that x is negative 4. The answer here 4 is the same as the 4 here. It just so happened that the signs here indicate their directions. Okay? So let's solve sine, cosine, tangent, cotangent, secant. We don't need to solve for the cosecant because it's already given to us. What is the sine of beta? Opposite over hypotenuse, negative 3/5. The cosine is adjacent over hypotenuse, negative 4/5. And then tangent is opposite over adjacent, 3/4. Therefore, the cotangent is the reciprocal of this, 4/3. And then secant is the reciprocal of this, negative 5/4. Cosecant is the reciprocal of sine. Look, it's the same, oh? Negative 5/3 and then 3/5 negative. They are reciprocals. So basically, that's where we end the first module.